High-carbon steel, especially 1095, holds immense promise for any bladesmith. Simple, potent, and capable of superb hardness and edge retention. It is clay for legends, shaped by fire and the hammer. Its carbon is its greatest strength when handled correctly. Blades stay razor-sharp through demanding tasks. The beauty of 1095 lies in straightforward greatness, but its strength makes it unforgiving. It demands respect and mastery of thermal processes. One lapse in heat treat can shatter a masterpiece. Overheating grows grain and breeds brittleness. A wrong quench can crack or warp beyond repair. Mastering 1095 is a rite of passage in heat control. This guide walks you through essential steps to success. From preparation to final tests. No shortcuts, just method. We'll break down forge welding and San Mai into simple moves. Before sparks fly or hammers fall, build a safe workspace. The forge is controlled chaos. Heat, debris, powerful machines. PPE is non-negotiable. Safety glasses or, better, a face shield. Protect against hot scale and metal shards. Wear fire-resistant clothing, leather, cotton, or wool. Avoid synthetics. They can melt to skin. Use leather gloves, but be ready to drop them if lit. Ventilation matters. Open airflow is a start. A hood is better. Monitor CO. Keep clutter clear and combustibles away from heat. Maintain an unobstructed path around equipment. Know your extinguisher, Class B or ABC, and keep sand or water handy. Learn on-off and e-stops. Never reach near dies under power. Grinders throw sparks and dust. Eye and lung protection always. Maintain a firm tong grip. A slip can become a projectile. Inspect cords and handles regularly. Fatigued? Hydrate. Step away. Your best project is finishing the day uninjured. Strong welds start long before the fire, with meticulous prep. Any contamination creates barriers and inclusions that cause delamination. Use an angle or belt grinder to reach bright, raw steel. Pay special attention to edges and corners. Seal the whole seam. Don't touch clean surfaces. Skin oils can ruin a weld. Handle by unground sides or wear clean gloves. Add small tacks or tight wire to keep layers aligned to heat. Brush off grinding dust. Some wipe with acetone. Let it fully evaporate. It may feel excessive, but clean prep is the secret to consistent welds. Minutes spent now save hours of frustration later. A clean start gives you a homogeneous billet, the bedrock of a great blade. Now the fire can do its work. Bring your tacked billet to life at true welding heat. For 1095, aim for bright yellow, roughly 2300 degrees. The surface will shimmer. Carbon is mobile and ready to fuse. Heat evenly. Cool spots won't weld. Hot spots can burn. Apply flux at bright red to orange. It shields from oxygen and dissolves oxides. Let it melt and flow between layers. At welding heat, move with purpose. Light, rapid blows, end to end, to set the weld. Sparks and expelled flux are good signs. Don't hammer as it cools. Shear risk is highest now. Reheat, reflux if needed, and repeat with slightly firmer blows. 2 to 3 heats typically ensure a solid bond. Then begin to draw out, but only at hot working heat. A good weld is silent and seamless, the quiet reward of precise heat control. San Mai, 3 layers, combines a hard 1095 core with softer outer steel. The result? A sharp, hard edge on a resilient body. Taco method. Fold the soft steel and insert the core. Stack method. Soft, core, soft. Simple and fast. Channel method. Mill a groove in soft steel and fit the core. All mating surfaces must be impeccably clean. Adding San Mai mid-process? Stop, re-clean, and assemble anew. Dirty cores guarantee delamination and failure. Heat all 3 layers evenly and set every seam carefully. Ground and etched, San Mai reveals beautiful lines and serious performance. Pull it off and you prove skill and control. Fail the welds? A simpler solid blade would serve you better. San Mai is classic risk versus reward. Choose wisely. With a solid billet, mono or San Mai, shape it into a blade. Draw out at orange to yellow heat, lengthening and thinning efficiently. Don't hammer too cool. Ineffective and invites microfractures. Start with the tang, then work forward to set length and width. Too little starting stock yields lean blades that miss parameters. Establish distal taper and a narrowing profile for balance and bite. Forge in the bevels. Precision here saves grinding later. Forge the point and keep the blade straight and true. Check progress against your blueprint or competition parameters. Normalize, heat slightly above critical and air cool, 3 cycles. It refines grain and relieves stress for a safer quench. Skipping normalization risks warps and cracks. Make it part of your ritual. Heat treat transforms workable steel into a hard, edge-holding tool. For 1095, austenitize around 1475 to 1500 degrees. Non-magnetic at critical is a reliable cue. Heat evenly and give a brief soak. Too long grows grain. Quench in fast to medium oil. Move gently to break the vapor jacket. Water is risky for beginners. Cracks and warps rise sharply. Post-quench, it's glass hard and brittle. Handle with care. A fresh file should skate across a properly hardened edge. If warped, you have seconds to make gentle corrections before temper. Don't wait. Temper right away to relieve internal stress. The quench is dramatic, but timing and calm execution make it succeed. Right after quench, the blade is hardest and dangerously brittle. Temper between 350 and 500. 400 is a strong starting point. Run 2 2-hour cycles, cooling fully between them. Tempering precipitates carbon, relieves stress, and adds toughness. With a torch, chase temper colors. Light straw to bronze for knife edges. Keep heat moving. Localized overheating softens the blade. After temper, sharpen and fit the handle. Expect edge holding and impact resilience. Poor temper or overheated billets fail. Patience here makes tools you can trust. Balance is the hallmark of a proper heat treat. The clock is ticking, the forge is roaring, the pressure immense. The plan: weld the bars into a robust billet. The twist forces a San Mai pivot on the fly. He stops, re-cleans, and rebuilds, risking delamination. Under pressure, incomplete welds hide beneath the surface. The test reveals faults. Unwelded seams and pre-existing cracks fail catastrophically. Another smith chooses simplicity, cleanliness, and solid welds. Even heating pays off. Quench to a straight, glass-hard blade. After temper, it's razor-sharp, tough, and fundamentally sound. Under pressure, execute a simple plan perfectly. Success is making the right choices, one heat at a time.